So today we're going to continue going over section 4.5, and I'm going to address some topics that it seems that we are still struggling with. So on all of the graphs on the worksheets that we've been doing, the axes have been predetermined for you. And just like when we graphed angles and we drew our angles in standard position, it always makes life easier if you get common denominators. So for example, instead of thinking about pi over 2, you would think about it as a 3 pi over 6, or a 4 pi over 8, or for that matter, a 12 pi over 24. So all of these are equal to pi over 2. They would reduce down. You just need to change it to get common denominators. So for example, let's say our denominator was 8. If this was 4 pi over 8, that would make this be 2 pi over 8. So you should be able to figure out what every line represents to know where to plot your value. Similarly with my pi, you could write it as 3 pi over 3, or a 6 pi over 6, or a 24 pi over 24. You need to get common denominators so you know where to plot your values on the axes. Next issue I'm noticing is that we're having trouble adding fractions. This is not anything new. This is the same concept as what we've done before. You need to get common denominators in order to add fractions. So for example, if I need to add a pi over 8 and a pi over 12, you must get common denominators. The common denominator between the two would be 24. So you need to multiply top and bottom by 3. And over here you'd multiply top and bottom by 2. So this would become 3 pi over 24. And this would become 2 pi over 24. So the sum of these two fractions would be 5 pi over 24. Again, in order to add or subtract fractions, you must have common denominators. Last skill I want to go over is dividing fractions. And again, nothing new. We did this when we found the trig coordinates, when we had to find tangent and you had to do these crazy radicals divided by radicals. Now we're just applying it to pi, but the concepts remain the same. So let's say I have a 2 pi over 3 and I need to divide this by 4. So for example, when you find your period over 4, if you had something to this effect. Just like when we divided fractions with square roots, it's still the same. You keep, change, flip. So I would keep the 2 pi over 3 and I would multiply by 1 over 4 because technically this is a 4 over 1. So when I divide these out, keep, change, flip, I end up getting 2 pi over 12, which can reduce to be pi over 6. So those are some concepts that I see when I'm looking at your worksheets that you've been turning in. Those are the 3 concepts that I see that we are struggling with. Also, don't forget your amplitude determines your height. So 2 quick examples. So if we do y equals a negative sine of 4x. So remember, our amplitude is a negative 1. Let's do our starting point next. Our starting point is c over b. And my c value is 0 divided by 4. So my starting point is 0. My period is 2 pi over b, which would be 2 pi over 4, which will reduce to be pi over 2. And then to find our period over 4, I have to take my period value, which is pi over 2, and divide this by 4. And again, we keep the top, and I flip the bottom. So what we are adding each time is a pi over 8. So my x1 value will be 0, because that's my starting point, and if I add pi over 8 to that, we get pi over 8. Then we will get 2 pi over 8. And then we'll get a 3 pi over 8. And lastly, we will get a 4 pi over 8. So I'm not going to reduce these because I think it will make it easier to graph this. I'm going to make the axis look just like your worksheet so you understand again how to graph this. So when I switch the screen, we're going to start by setting up the graph the way it was on the worksheets. And the worksheets typically skipped a line and went pi over 2, pi, 3 pi over 2, and so on. So I'm dealing with a denominator of 8, sorry. So this right here, I would like to rewrite to be 4 pi over 8. which means this location right here will have to be 2 pi over 8, which then you can assume that this will be 1 pi over 8, and that will be 3 pi over 8. And here's our 0. So this problem was a sine function, and it went down since it's negative, so I start on the intercept. My first value, which was pi over 8, which was located at this first tick right here, will be at a min, intercept, max, intercept. So here's your sine wave. Notice the period was very small, so the wave happens in a very short distance. This could continue forever and ever, but we only want one period. We don't need to continue graphing it, and that could go in the negative direction as well. Notice when you're looking at this graph, you should see the cosine wave emerging. If I cut the wave off from here to here, there is the cosine wave. So sine and cosine have a lot of similarities. Okay, so example on cosine. So we're going to do y equals 3 cosine of a 6 theta. So our A is 3, B is 6, C is 0. And I was looking at your worksheets. A lot of you identified A, B, and C, and then you wrote the incorrect amplitude. If A is 3, your amplitude is 3. My starting point is C over B, so 0 over 6, so my starting point is 0. My period is 2 pi over my B value of 6. So 2 pi over 6 will reduce to be pi over 3. And then our period over 4 will be pi over 3 all over 4. And we keep change flip, so I keep the pi over 3 and I multiply by the 1 over 4. So what we are adding each time is pi over 12. So our x1 value is 0. Our x2 value is pi over 12. Our x3 value is 2 pi over 12. Again, we know that reduces to be pi over 6, but it's easier if you just keep it like this, so when you go to graph, everything makes more sense. X4 is 3 pi over 12, which again, you know that this is a pi over 4, and x5 is 4 pi over 12, which is a pi over 3. And we know this one was pi over 6. Okay, again, keeping it in the 12 so that way it makes it easier to graph. So now when we create our picture, so we're going to draw our xy axis, and we're going to make this one a little bit more spread out because the period is very small. The wave happens in a very, very short distance. So we're going to say that this right here is pi over 2, and over here is pi. So we have a denominator of 12, so to make this work in our favor, we need to get 12s. So I'm going to rewrite this down here as a 6 pi over 12, and I know this is a 12 pi over 12. And because I know this is a 6 pi over 12, we can assume that halfway would be 3 pi over 12. And if this is a 3 pi over 12 right here, we can assume that 1 pi over 12 probably falls there. 2 pi over 12 falls there. 3. Here would be a 4 pi, 5 pi, and a 6 pi. And it's okay that it doesn't fall exactly in the center. Okay, so our first value is at 0. And since it's cosine, we're up at a max. And it's a max, not a min, because A is positive. So our first dot would be here. 1 pi over 12 is located right here. 2 pi over 12 will be down at the min. 3 pi over 12 will be here. And then 4 pi over 12, which where we end up will be right here. So again, we're concave, convex, and then concave. So here is our cosine wave. So I hope this helps clear any questions that you have on this lesson. Remember, if you desperately need more help, you may comment on these YouTube videos and I can comment back to you and answer any questions that you have.